about our 101 on SSI and decentralized identity. I'm really glad for everybody who's joined. You can put your questions in the chat window. But to get started, I wanted to take everybody through a bit of background on what self-sovereign identity is and how it sort of applies to decentralized identity. So maybe to begin with, the first question that a lot of you might have is, what is identity? And one sort of take on this or understanding of it that we tend to use quite often is it's all about the government-related documents or passports that are issued to you. So your passport is obviously one of them, your driver's license, but that's not the only aspect or thing that counts as identity. Quite often you have it in a digital form. And how do we check all of that? We check that by saying, you might have encountered this online, show me a picture of your passport, a selfie, and these two documents from so many different ages ago. And the company that receives this, let's say you're doing this to open a bank account, will often take these pictures and go to the agencies that they came from, or some sort of company that can talk to those agencies where it came from and say, can I trust these documents? Can I trust that this passport or driver's license is true and accurate and was actually issued to a person with that name? There's a name for this because of the way that it's quite often done. It's called selfie, scan and check, because you're often taking a selfie, scanning a document, and then it gets checked by some company. The issue with that sort of process is obviously because you're taking a digital picture of a physical document, and obviously this has become increasingly even more complex because of things like deepfakes that are happening right now. It takes minutes to hours to sometimes weeks to go and verify if these documents are true. It takes time, effort, and money, and quite often a significant amount of money. A very basic KYC, or Know Your Customer check, as it's called, could take anywhere from $5 to $10 to go and do. A criminal record check, which is a bit more comprehensive, could take anywhere from $50 to $100. Something like a company background, which is far more complex and has many, many different aspects to it, because there could be multiple directors, there could be complicated structures. It could take somewhere up to hundreds of dollars to go and do. So if you're doing this digitally, and you know, people talk about digital identity, like some of these processes often cross across from physical documents to digital documents. But if you think about just the word digital identity, sometimes people think this is the same as usernames or passwords, or the login with Google, login with Facebook, login with Apple buttons that you see online. But that's not really fully digital identity either, because all that's doing is it's giving you a mechanism to log on to a specific website. Even if you don't particularly have a password, for example, if you're using login with Google or login with Facebook, all that's doing is it's creating a shortcut or a replacement for usernames and passwords. But your digital identity is a lot more than that. Your digital identity is all of the preferences, all of the various different aspects of your online persona or your offline persona that come into play. Digital identity, or identity in general, doesn't just relate to legal identity. So the example that I wanted to show you here is my X or Twitter account, as it's known. I have a particular handle on there, which I'm known by. That could be considered to be part of my digital identity. But also, I go by my actual name, or my actual face is on there and published. But you could also be going by there by your real name, by your legal name, but not your real picture. So that's where you start getting into the complexities that come in when talking about identity, is because it doesn't just relate to legal identity. You might have sometimes seen pictures like this on certain websites. This is a thing called Gravatar. So gravatar.com, the most common place where it gets used is if you've ever commented on a blog, on a Tumblr, or on some forum online, you might have seen that it creates this sort of auto-generated image to depict you if you've not uploaded a profile picture yourself. And this is done based on the email address that you've got associated with that service. That could be a form of digital identity as well. And when we first started off, and that's, to go and say, there's this sort of very popular saying, or I guess there's this very popular saying, and this references the image that we had at the beginning, which is, on the internet, nobody knows you're a dog. And that references the fact that your digital identity doesn't just have to be legal identity. It could be something that is pseudonymous and that you go by as well. And how does this sort of identity data get stored right now? The simplest model that you can think about is something called siloed identity, which is every company that you interact with holds your data on their databases. And this is by far the most common model of a form of digital identity. Slightly more complicated than that is something called federated identity. And this is similar to when you use login with Google or login with Facebook. But something crucial to remember there is all it's doing is it's a replacement to usernames and passwords. So it just replaces those two fields in the form. If you had to take all of your preferences or settings that you have from one app to another, that usually does not come across in a federated identity system. So the big question is, if instead of having a federated identity system or a siloed identity system where all of this information is stored on the database of a specific company, what if you had your own copy that you could go and show to other people? And the difference that sort of starts making is, if you think about the current model of identity, it's all based around sending your data back to some very large big tech companies. Let's say you get a newsletter in your email inbox. Quite often this is sending data back to places like Google, MailChimp, Facebook, data that is not in your control, and you don't understand how that gets used. And so the idea of self-sovereign identity is that you should have a digitally tamper-proof copy of the information that relates to you. It could be about you as a person. It could be a company, if you're a company. And the idea here is that is not to say companies should not have information about you, because sometimes it does get misunderstood as that. But to say you should have a digitally tamper-proof copy that you can take along to anyone. And what that gives you is a lot of flexibility and freedom in whom you choose to do business with. So going back to that first example of how does identity get checked right now, you're often uploading pictures of physical documents. If you had a digitally tamper-proof copy, you could go through these ID checks in seconds, and they could happen in a privacy-preserving fashion. They could happen in seconds, be more efficient, and be trustworthy because they're digitally signed and cryptographically tamper-proof. And it becomes a lot easier to check that fact if it's natively a digital document. And it can also be privacy preserving because a lot of the cryptography has moved to a point where perhaps you can only reveal the bits that are necessary. And finally, it can also happen significantly cheaper because the cost of carrying out such a digital check could be cheaper. If you think about how this then sort of starts working as a system, when you have a digital ID document like a driver's license, sometimes you go and show it to people not to prove that you can drive, but you go and show it to prove that maybe you're trying to prove your age. Maybe you're going out to a nightclub and you need to prove the name and the age that you have. Maybe you're buying alcohol. Maybe you're opening a bank account, and what they're trying to understand is what's your legal name and what address do you live at. So what's quite powerful once you make it portable is the fact that it's not just the original purpose for which that ID was issued that it becomes useful in. It also can be used in a vast number of other situations. And sometimes you need to check if it is valid now, sometimes you don't. And an example of that is a driver's license or a passport might have an expiry date on it that says this is valid for 10 years. Maybe, it's just freshly minted and it's come across to you. But you could also say report it as lost or stolen. I've had that sometimes when I found, I thought my driver's license was lost, but in reality it wasn't. And I found it, much later stuck in a drawer somewhere, but because I had reported it as lost or stolen, I was issued a new driver's license that came along and was delivered to my address. So now I have two documents, and they're both real documents. But if I actually wanted to drive or rent a car with one of them, only the latest driver's license works because that's the valid one, because the other one has been revoked. Why do people think this sort of self-sovereign identity system will be the way of getting back control of their data? A lot of them feel that the mechanisms they have don't really give them control on the data that gets shared with companies and how it gets used. And a lot of people don't necessarily believe that the existing data privacy regulations are sufficient for giving users control on their data. If we specifically talk about emerging standards such as Web 3.0 or blockchain, many people think that Web 3.0 sort of apps and so on will require some native form of digital identity. And why do they care? Privacy is a big part of having more control or privacy on their personal or company data. But then very soon after, we start looking at other aspects of it, which is being able to make the data portable, having a more democratized system that gives them access and is not necessarily in control of specific companies, or the efficiency gains that come across compared to the existing methods, as well as being more inclusive than existing systems and perhaps scope for commercial gains or profits from the data, which they currently don't get from. But what's in it for a company to go and look at why they should use self-sovereign identity? Well, one of the big things that they tend to focus on is they want to reduce the risk for compliance that they have. These regulations could be data privacy regulations or anti-money laundering regulations that require them to go and collect data, as well as wanting to stay on top of the technology curve because they know that the regulation that is coming along makes SSI or self-sovereign identity adoption more viable. One example of this is something called the EU Digital Wallets Initiative, which it looks at having the EU governments give all of the data that is related to an individual natively in a digital format rather than sending you a letter or sending you a PDF. We have talked a lot about privacy, but one of the things that I say quite often is that people say they want more privacy the same way that they say they want to exercise more, and that's quite an important point. If you went and asked someone, would you like more privacy, they would probably say yes, but would they necessarily go out of their way to change their behavior? Perhaps not necessarily. So one of the core principles in SSI is to make it as simple as possible, because the real things that people often want out of it is to go and port their data along to a different system. Your digital wallet should be able to hold any kind of digital trusted statement. An analogy that I tend to use is that think about a highway and how highways get used by cars from many different brands and of many different shapes and sizes. The digital identity is just like a highway. Those are the common standards and specifications on which your information can move about. And that's a real big part of how digital identity or decentralized identity gets achieved. One of the best ways to then go and start explaining this is something we have published on our website called learn.cheqd.io. Learn.cheqd.io is this website where you can go and start understanding the basic building blocks of how self-sovereign identity works. One of the parts of this is something called decentralized identifiers, or DIDs. They look something like this, a bit like the domain names that you enter into your browser and go sort of browse on the web. So you have a method part, which is in, for example, a DID : checked, and then you have some identifier that comes afterwards. A website that allows you to go and try this in action is something called dev.uniresolver.io, where you can enter one of these DIDs that exist and be able to go and read what's written on this DID. And what does this actually achieve? Well, compared to most other blockchain use cases, which are quite often based around going and writing some data to a blockchain, instead what you have in decentralized identity is you go and write cryptographic proof or cryptographic signatures that attest to the fact that some data is tamper-proof. It looks a bit like this, and obviously there's a lot of different elements here, but the key thing to remember is what it allows people to check is some piece of information that has been given to you signed by the correct public cryptographic keys. And if it is signed by the correct public cryptographic keys, then you know that it has not been tampered, which is the other sort of terminology that gets used in the SSI space a lot, and that is verifiable credentials. Verifiable credentials are digital credentials that are often issued as a file that can be stored within a wallet. And this file could go and encode things like your passport, your driver's license, your birth certificate, your education records, your health records. And these are signed using the public keys or the cryptographic keys that were published within a DID or a DID document. You also do have some other elements to go along with this. Quite often, these could be things like, what does the structure of the data look like, which we'll come on to in a bit. And so if you think about your wallet should be able to hold any kind of trusted statement. The kinds of digital credentials in SSI come in various different shapes and forms, much like different car brands. But what's important is that people should be able to hold it in a wallet and be able to share it with the people they want to, without necessarily having to care what sort of format these are in the background. And that's one of the core principles that we have within the cheqd network as well, is to go and support as many of the cryptographic standards as there are in the digital credential standards. So if this sounds good and amazing, what are the reasons why self-sovereign identity hasn't been adopted so far? So going back to the survey that we ran a couple of years ago, some people feel that the technical standards are not stable or mature enough, but as I said, this was a couple of years ago, back in 2022, when we ran the survey. The space has moved along significantly since then. It has also improved in aspects such as the lack or limited interoperability, and being able to just understand what is the actual value or the return on investment for a particular company in implementing all of this. And so speaking of that value exchange, or why should a company go and do it, an analogy that I wanted to give is, instead of maybe spending that $5 to $10 processing a picture of a document like people do now, An example of where this is way cheaper and way simpler is the product that is from Stripe Identity, where their pricing is significantly cheaper. It's somewhere close to $1 or 35 cents. And we want to bring the same sort of model along. Stripe is obviously a centralized service, but we want to bring the same type of system along in a completely open and decentralized fashion. So cheqd is not just another layer one that allows you to go write these decentralized identifiers or issue the digital credentials. We want to build a mechanism that allows you to go and charge for them as well. And it might look something like this. If you as an individual have some data that has been issued as a digital credential, you're the credential holder. The person or the company that gave it to you is a credential issuer. We've built the mechanism so that the people or the companies that you show this to, the credential receivers, can make a payment. Sometimes this payment might go directly to the credential issuer. For example, maybe you have a digital credential that's been issued by your bank. The bank gets the payment. In other scenarios, maybe it is your personal browsing history, which obviously isn't signed or isn't attested for by a bank, but could be valuable to somebody like an advertiser. In that example, perhaps the value goes directly to you as the credential holder. And we've built the blockchain network that we have, not just to handle the cryptographic sort of like, digital decentralized identifiers, but also to be able to effect the exchange in a privacy preserving fashion. And what we think this sort of starts changing is it starts lowering the cost of having trusted data flow around in an ecosystem. Because it's happening in a digital fashion, the cost could be significantly lower. And this will lead to many, many different ecosystems. Like the example that I gave you of the driver's license being used for driving, but also being used to go open a bank account. Enabling the flow of this data where there's a value exchange associated could make it much more lucrative for your data, which is in your control and you choose how much of it gets shared with whom, can easily be moved around by you from, say, banking to healthcare to insurance to places like travel. What this starts creating is a bit of a flywheel for SSI adoption. Better user experience, privacy, and security, which SSI brings along, leads to more people wanting to use this kind of technology. And as more places start adopting SSI, more organizations start natively issuing SSI. And that's the normal model which so many different companies that work in the SSI ecosystem try and do. What's quite unique about cheqd is because we are also focusing on the value piece of this. The lower cost structure for creating this trusted data leads to lower prices for consuming this trusted data, leading to overall a system that is more in people's control and with lower prices for consuming trusted data. What sort of commercial models could be applied? Now, we don't necessarily go and put a price for these digital credentials that are anchored on our network. And we don't set the price. We also don't go and specify what sort of payment model could be used. That is completely up to the issuers or the people who are building these use cases on top of our network. Some of them are focusing on things like education, other people are doing things like banking, healthcare, and so on. And even outside of these sort of traditional use cases, we've got products that we've built ourselves within cheqd, such as creds.xyz, which is all about Web3 reputation. You are completely free to go and build the commercial model that makes most sense within your own ecosystem. So one of these examples is Verifiable AI's issuer, and that is an example of you go and show the credential that has been issued to your bank when you're getting a mortgage. The mortgage provider who's the recipient in this example, or the person verifying the information, they go and pay the bank, which is the issuer of the credential. We also enable things like being able to pay for these transactions in regulated stable coins, which some companies would like to have. And so what else is cheqd doing differently besides enabling you to issue these decentralized identifiers and digital credentials? Well, one part of this is what are the other files that you need when you go and process these digital credentials. So an example that I gave before was what the structure of a credential looks like. So this is a real live example. This is something called a schema. So when you have a driver's license, there's specific spots in which the information is, and that means something specific. It means that this field is a first name, or this field is a last name. Those are quite important when processing whether it's a traditional ID document or a digital credential. These also sometimes tend to change over time. There have been occasions on which the format of a driver's license has changed and the places or the fields have switched around to something else. And so whenever you therefore present this credential to someone, they need to understand what has been that change in the structure of how the data is represented. So although they are both driver's licenses, perhaps the schema has itself evolved over time, and that becomes important in the sort of timescales that we talk about when you consider digital credentials. If a computer or a system was unable to understand the fact that the schema behind a particular type of credential had changed, they might end up saying, I don't actually recognize what is being presented to me here because it doesn't look like how it's supposed to look. So it's very important for these things like schemas to also survive over long periods of time. You also want to not just store it on a single website or a single system. A good reason for that is no matter how large a company is or how sophisticated they are, sometimes their systems just go down. This is a graph of the traffic that was going to Facebook. And during this particular time, there was about 6 hours on which they had a major outage and nothing worked. But just because of that, any apps that were using login with Facebook also stopped working. And this has happened time and again. This has happened when, just this week, X went down. There have been occasions on which LinkedIn, Instagram, WhatsApp, any service that is online that you can think of has had occasions when they've completely stopped working. And so the fact that these could perhaps be stored not in a single place but in a decentralized fashion also starts becoming important. You might think storing it in the cloud is one solution, but if you think of cloud providers and the sort of market share that they have, most of it is split between Amazon Web Services, Microsoft Azure, and Google Cloud. And there have been known occasions on which an outage or a problem with Amazon Web Services or Microsoft Azure has taken out loads of different apps and services. Then you have this concept called link rot. What this graph shows is a 10, 20 sort of year period over which a particular academic group went and looked for how many of the links still work. You might have sometimes seen that if you click a link on a document or something that you found online that's from a while ago, it leads to a page that says 404. This thing was not found. That is an example of link rot. And what you see is when you start looking at a 20-year horizon, almost more than 60 or 70% of the links from that time in the red section of the graph are rotten or they don't work anymore. And when you consider things like digital traditional identity, a passport is issued with a 10-year time frame. A degree certificate has no time frame. A degree certificate lasts forever. A birth certificate lasts forever. It doesn't have an expiry date. And so what becomes quite important to consider when you're building digital credentials is, how does this perhaps survive the test of time? And so what are we doing differently to fix these user experience and longevity issues? We created a standard or a specification rather called DID linked resources. So DIDs are decentralized identifiers, the cryptographic proof that is stored on our blockchain that I mentioned before. But we went and built a system that goes and allows you to publish any additional files beyond just that cryptographic proof that might be needed to process a digital credential. An example of this perhaps is, what does a passport look like, which is shown over here. So at the beginning, you have the DID cheqd mainnet. You have a unique identifier. And then after that, what you're going and saying is, show me the passport schema or the structure of what a passport looked like, and show me what it looked like on this particular date, on the 1st of July 2022. And what that sort of starts building is a mechanism through which all of this information could be persisted over a long period of time. The other example of what this could be used for is, I love taking the analogy, say, of Apple Wallet or Google Wallet, which many people have on their phones. And if you've ever, traveled internationally, you might have received your boarding pass as a digital pass within Apple Wallet or Google Wallet. And so there's a digital representation of the information related to your flight, but you also have a slightly different visual representation. My boarding pass looks a specific type within Apple Wallet, and that helps me pick it out from the list of all of the other things I have. It helps me pick it out from all of my other bank cards. It helps me pick it out from my loyalty cards. And even within the boarding pass, you might have, say, a slightly different color or a slightly different background based on what status you have with the airline. So you might have a gold-colored pass or a silver-colored pass or a white-colored pass or a bronze-colored pass. The visual representation of digital credentials helps users in the user experience of being able to pick them out. And that's quite important because sometimes you see in SSI demos that there isn't really attention that has been paid to what does the digital credential look like. And it's just presented as some sort of table. If you want to build something that is fun and engaging, you also need to pay attention to how easy is it for users to interact with the system. And that's one of the core sort of areas, like how can we make privacy-preserving digital credentials fun and a daily habit. That's everything that I wanted to talk about today. And the two places where you can check out for more information is learn.cheqd.io, which I briefly showed earlier. That has a lot of the basics of how self-sovereign identity and decentralized identity works. And also docs.cheqd.io, which is a bit more technical and dives into how all of these basic building blocks, our various different software toolkits and everything works, which we'll be covering in a future webinar. Thanks for having me today, and I hope that was useful for people to get a bit of a background on what self-sovereign identity is. Thank you.